I would like you to have a look at these 4 images. They all contain the same organic compound. Let's first have a look at what these organic compounds are in each of these objects. This is a candle and it contains the organic compound paraffin. This, of course, this flame comes from lighter fluid inside that combusts, and that lighter fluid inside of this lighter is butane, the organic compound butane. This is camphor gas for heating and cooking, and it contains the gas propane. And these bananas here all give off a certain organic compound called ethene that aids in their growth. So you might ask what this common organic compound is. It is called hydrocarbons. All of these substances, paraffin, butane, propane, and ethene, are all made up of only carbon and hydrogen atoms. And so we put the 2 words together like a portmanteau and it forms the term hydrocarbons. So we call these organic compounds hydrocarbons. In this video, we will look at what hydrocarbons are. Hydrocarbons are made up of only carbon atoms and hydrogen atoms. A good example of this would be something like methane gas. Methane gas, of course, has this molecular formula, CH4, and it has this structural formula, a carbon with 4 hydrogen atoms bonded to that central carbon. We say that it is a hydrocarbon because it only consists of carbon and hydrogen atoms. Now, we can also get other hydrocarbons that look like this. And if you look at the bonds between the carbon atoms, we can see there are only single bonds between these carbon atoms. If there are only single bonds between carbon atoms, we say such a hydrocarbon is saturated. It means that the carbon atoms are bonded to the maximum number of hydrogen atoms that it possibly can bond to. Now remember that carbon can make only 4 bonds, or in total a maximum of 4 covalent bonds to other atoms. So if it is bonded to another carbon, if we zoom into this carbon, if it is bonded covalently with a single bond to this carbon here, it still has 3 bonding possibilities left to make a bond to other atoms. And so it will bond to these 3 hydrogens here. The middle carbon has 2 single bonds to other carbons, and so it can bond to 2 other hydrogens, top and bottom here, while this carbon has a single bond to this carbon, and it has therefore 3 other hydrogens that can sit on it. There are 3 main types of hydrocarbons, namely alkanes, alkenes, and alkynes. The alkanes have only single bonds between the carbon atoms, while the alkenes have double bonds between, or at least 1 double bond between carbon atoms, and alkynes have at least 1 triple bond between carbon atoms. This compound here is an example of a saturated hydrocarbon because it only contains single bonds between the carbon atoms. Likewise, we can get unsaturated compounds, organic compounds or hydrocarbons that has at least 1 double or triple bond between the carbon atoms. In such a case, we say that these are unsaturated hydrocarbons. An unsaturated hydrocarbon has its carbons not connected to the maximum number of hydrogens. If we look at these 2 carbons over here, of course, carbon has 4 bonding possibilities, but if it already has a triple bond that it makes, as in here, to another carbon atom, If it already has 3 bonds that it makes to another carbon atom, it only has one more position left that it can add on or bond to another atom. On this side, therefore, it will only make one additional bond, and this carbon on the other side will only make one additional bond. In a saturated hydrocarbon, each single carbon-carbon bond is a very strong bond, a covalent bond, which we in this case call a sigma bond. A sigma bond is a very strong carbon-carbon single bond. But if we look at unsaturated carbons, where we might have at least one or more double or triple bonds between carbons, then we have an extra bond. The first bond is a strong covalent bond, which we call the sigma bond. But the second bond down here, we call a pi bond. Now, a pi bond is a much weaker bond than a sigma bond and is established by the overlapping of p orbitals and hybridization in each carbon to form that bond. If you can predict, would you say that a saturated or an unsaturated carbon is more reactive? And what would the reason for that be? Which of these two types of compounds would react faster than the other with other substances? Well, the unsaturated hydrocarbon has a weak pi bond that can break very easily. And therefore, if it breaks, it can add on to this carbon and to this carbon other atoms, other elements. And so a reaction with an unsaturated hydrocarbon would be more reactive or taking place much faster. This reaction of a saturated hydrocarbon will be less reactive because it does not have a double bond, which is that additional pi bond between carbon atoms.